you have a security fire alarm panel, it's L1A, but it's just a small two-circuit panel. And then your L1C is the feed for your mini substation, they call it, which is really just a UPS system. So your L1C, and then there's a question that asks you what size conductor is feeded, and it is L1A is your server rack. L1A is the one that feeds the UPS system. So the mini substation is L1. Doesn't make any sense at all. Got it pulled out as L1A. Okay, so the mini substation itself is L1C, which is also the panel that's in the room. So it's L1C, and that's the mini substation, and then you've got L1A, which is security fire alarm. And the conductors that feed L1C are 2 number 8s and a number 10 ground with single pole 40 amp breaker. A single pole. Yeah, no, it's a single pole, what it says. How many of those we installed?
You're not sitting in a room full of electricians.
It probably means single phase, but usually a P by itself is a pole, not a phase, so I'm sure that's what they mean. I've got a set of these, I think. I'm just going over I'm on page 34, just in general.
Right, but I mean, we're not looking at no drawings, so. I mean,
Yeah, I'm trying to, I've got a set I'm trying to pull up.
We know it's number 8, maybe single phase, 40 amp breaker.
Mm-hmm. Yeah, the feed of it, it's a single phase 2 pole 40 amp. You look on the panel schedule. Dig it up, I don't know why I've got a list of class. And the breaker type for that panel is mellow, so there is no main there at the panel. It's just a sub thing.
So, under the question, what size of the main GEC or attached to building, it should be number 8. Is that?
No, that's a
Okay,
different
we're
question.
still working on the same. What is
The
the panel location?
yeah.
The first
Yeah.
question was what's the panel? And we've called it L1C, and we have number 8 feed, single phase 40 amp
Yep.
pole. That's all on that same question.
Yep. No, those are 2 separate questions, but that's on the same first line there in the book.
All right, so where's the next question, what size of main? Is that the one that we're gonna put number 8 on?
No, there are 2 questions within that first line.
Oh, okay, okay.
So those are really notes kind of to remind yourself what the questions are, but the one that I'm referencing on the second part is somewhere down the line somebody said that they had a question and asked what size conductors fed at L1C.
Okay.
So L1C is the panel that's located in the room, and then the conductors that feed it are number 8, number 10 ground. And then this is kind of the same things I've got in your book, so I'll just kind of put them in there so you wouldn't have to write as much. But the size for the main ground electroconductor, those 2 terms, guys, are terms that you just really got to put in your mind and keep them very clear. They're 2 distinct animals. And a lot of times these guys get pretty easily confused with the term ground and grounding and grounded, and you got to be careful that a neutral, just because a wire is white or gray, doesn't necessarily mean that it's a neutral. Okay, all white wires and all gray wires are grounded conductors, and they're conductors that we intentionally put to ground, but they carry current, right? And so a grounded conductor, they don't use the term neutral very often because it takes if you look at it as a single pole 20 amp circuit going out to receptacle, from a panel, you've got your hot coming out of here, your line side, okay? That white wire that comes off of your silver screw over here that comes to a terminal, that's not a neutral. It's a full current carrying conductor. And if you don't believe me, take it loose on the panel one day and ground yourself, put a load on it, see what happens. It will bias just as well. well, if not worse sometimes, than the line side will. So,
It's potential carrying conductor, correct? It's not carrying it all the time, only when it's a loader.
That's right.
So it has a return back.
exactly. So but it does carry the full current. So if you have a, if you have a single wire going there and a single wire coming back, regardless of what color it is, if it's two pole, then it's going to be, two different phases, but they're still, you have both those are current carrying conductors, and in this case, this would be considered or classified as one as well. Now, we split the tab though on this side and bring another phase over here, and I'm just going to kind of draw this over here like this, so they're kind of boxed in with that in the middle. Then this wire becomes truly what is then a neutral. So you've got A phase here and B phase here. I've drawn to better scale so they look a little bit more, same length and size here. This then, because of the characteristics of the sine waves being the same shape, same waveform, when they meet in the middle, since both phases are directly opposed at 120 degrees, they cancel each other out. Only to the point where they equal each other. And then anything that's left over is what's carried back on the neutral. So we call it carrying the unbalanced load, or the unbalanced portion. So the test question that gives an example of this was one I was asking, I guess it was you that had did you have the two water heaters? We had the two water heaters, multi-wire branch circuit. It was two water heaters, it was a 12,000, so 12 kVA, kW, and a 14 kVA. Telling you it was a 120, 240 volt servicer, and they wanted to know what was the amperage draw there on the neutral. And so the first 12 kVA on both sides of that is going to cancel each other out, right? We just carry the net difference between those two numbers on that. So what would be the load then on that conductor? 2K. Huh? 2. What's the amperage? That should be kind of a quick, that should almost be instinctive to you, just be able to grab a calculator. It just carries the net difference between those two numbers. So what's the net difference between 14 and 12? 2,000 watts, or in this, 2,000 watts. 2,000 watts, but to convert that to amperage, what do I do?
It's 11 amperes, no?
Yeah, you divide it by 120 or 240?
240.
240, right? Is the
So
whole
it's
system.
less, it's the half.
Huh?
It's amperes.
Right,
Yeah.
yeah. This is 2,000 watts, and then to get that, to convert that would be divided by 240 volts. Give you something less than 10. Whatever.
He lost me there at the bakery there.
Lost me at the bakery?
Yeah.
If you have a two-pole circuit, and this is what they call
Okay,
it.
no, are we on the water heaters, or are we on, okay, I'm just trying to figure out.
I'm using
how
water
long
heaters as an
these
example.
two water heaters, one of them's 12 kW, one's 14 kW, but they're both 240 volt water heater elements. Is that a fair statement?
No, and that's what I was unclear when I first heard that in the first guy, but the only way it can really be is if this was a water heater, for example. And then actually this one goes to another water heater. Is the way the question is kind of worded.
Okay.
And I'm with you.
And so both of them are 120 volts?
Right.
Okay,
Yeah.
well, I understand
Yeah.
that. Because that neutral should never carry anything on 240, period. I don't
Right.
know whether, what kW they are.
Well, some appliances will have a load on it, like your ranges, your dryers, and heavy
Right, because
electronics.
you got multiple loads, right, there, clothes dryer will do that, 240 volts on that, but their controls is 120. So they'll make that neutral current.
Yeah, the question, it's either worded funky or the translation that I get is a little off, but effectively what they're getting at is what's the net balance or net current draw on a multi-wire branch circuit that has two water heaters, 12,000 watt, and one of them 14,000 watt the other. My whole point was that this on a multi-wire branch circuit, that white wire that carries current carries a lot less than if it was a single pole 120 volt. If it was a single pole 120 volt, this one just by itself didn't have anything but just these two conductors on it, and a phase conductor and a line back, a load back, and that's a full, if this is the 1400, 14 kVA, then this carried 14 kVA back to the ground, right? But if you put on a multi-wire branch circuit, the net effect in is that the grounding conductor just carries the imbalance between the two. So whatever the net difference is between 14 and 12, which is the 2, And just as an example, to kind of help clarify what we were talking about, the use of the water heaters. And somebody just brought that up like 2 or 3 days ago, so I've really heard it. I think you had it, or you had it on yours, right?
See, you should be using 120 volts as the value, and not 240.
Well, both conductors combined on that ground conductor have a combined value of 240 volts.
But that neutral's only carrying back 120 volts.
Well, it's carrying back just the net imbalance between it, but and you're right, it's a 120 volt
Let's see,
rating.
it's trying to prove.
But if you're combining both of them for your math portion of it, it's 240 volts, because that's the total combined voltage between the two. So the combined load is 120, 240 volt load.
Well, I'm just trying to figure out how that would be wired up. I'm just.
We would basically share the neutral.
You'd have a junction box, and you'd have an A phase and a neutral coming down on one of them, and with the other neutral, the same neutral tapped together with the other phase conductor going to the other. Who would put a 12,000 watt water heater on 120 volts anyway? Really, the first time I heard it, I thought it was heating elements within the same unit. That makes more sense. But I don't know how you have 12,000 and 14,000 heating elements.
So that
Yeah,
one is always, the neutral's always bringing back a load, no matter what.
Well, I mean, like with a water heater, you normally don't even run a grounding conductor. So I mean, it's a stupid question from the beginning, but all they're trying to do is use that. And it's a poor example, I agree, but the first time I heard it, I thought they were talking about the derating of the grounding conductor, which you're permitted to do if it's a range or a dryer calculation under a residential standard method. So I thought it was a 70% value of whatever the phase conductor would be, and so, but it's not really for a net amperage that's carried on the ground conductor when it's in part of a multi-wire branch circuit. So the total circuit, forget about the water heaters, the total circuit is rated at 240 volts. So let's go back and see if we can make it a little bit more clear, and then I think the answer is 8.